Alright, hopefully you won't hear the sound of my laundry going during this, but if so, then oh well. This one's not too uh, tricky. There's a lot of just tedious things. So let's start with this table for z mod z3 with plus. So we got 0, 1, and 2. And here we've got 0, 1, and 2. So what do? Add 0 to something, you get it back. So that does this. 1 plus 1 is 2. 1 plus 2 is 3, which here is 0. Same thing here. 2 plus 2 is 4. And that wraps around and becomes 1. Okay, cool. There we go. So now for one that we need to... This is a little more tedious. Now we've got 6 elements. We're still just adding them, so it's not too bad. Probably should have just drawn this out and done this later, but why do that when I can not do that? So again, these stay here, because that's how these work. Alright, so this becomes 1, 2. This basically just kind of, once you get through 1 through 2, 3, 4, 5, it becomes 0 again. There isn't really much else to this. It's not a very interesting table. You start here and then 3, so that will increase by 1 to 4, then to 5, then to 0, then to 1, then to 2. And so you see a pattern here, and you just keep going with it, and you get the whole table. And so there you go. Alright, so now we gotta determine all the subgroups of this group here. So it's here. So by Lagrange, for any subgroup, and this is a notation for subgroup that I learned recently and have started adopting. H less than G to mean subgroup, and sometimes you might be like, oh, well, maybe you'd want to write this to mean subgroup and not include it if you want it to mean a strict subgroup, but that's not the notation I've used. I guess this isn't necessarily great notation, but it saves you from having to write out the word subgroup, except that for the fact that we wrote out the word subgroup here. And also it makes it nice for a normal subgroup. The notation I learned was that triangle there, so it's just like, it's this, and then you just close it, and it becomes normal. So it's kind of similar to that. So anyways, that's a huge aside. So for any such subgroup, the order of G is equal to the order of H times the index. Since order of G, which is the order of Z mod Z6, is 6, the order of H must belong to 1, 2, 3, 6. I guess I didn't really need to write this part out, because that's just part of Lagrange, is that it has to, the order division thing. So anyways, the cases of norm H equal 1 and norm H equal 6 correspond to H being just the 0 element and H equals G respectively. And that's pretty clear, because you can't have any other possible groups or subgroups of those sizes. So anyways, so let's consider the other possibilities. So if norm of H equals 2, then H must have an element of order 2. So looking at our table, this implies. So let's look at our table and see if we can find any elements of order 2 on the diagonal. So basically what that would mean is that if you add something to itself, it's 0. And so adding something to itself is going to correspond to looking on the diagonal. And we see, of course, oh, here we go, we found one, 0. Well, 0 doesn't have order 2. 0 has, that's order 1 because it's 0. But we have this other one here, and it's 0. And this 0 here corresponds to 3. So our table implies that 3 is in H. But we know that 0 is in H, and so H has 2 elements, it has 3, it has 0. Well, there we go. H is 0, 3. Right, and this is and if you're worried about this, like, wait, do we know this is a subgroup? I mean, look at it. 3 plus 3 is 0. 0 plus 0 is 0. 0 plus 3 is 3. It's fine. Inverse of 3 is 3. Inverse of 0 is 0. Yeah, it's good. Don't worry about it. Okay. So now, suppose norm of H equals 3. The elements of order 3 are, well, let's look at the table. 1 plus 1 is 2, 2 plus 1 is 3, that's no good. 0 is obviously out. 3 is obviously out because it's of order 2. So what we have left is 2, 4, and 5. 2 plus 2 is 4, and 4 plus 2 is 0, so that's good. So 2 is 1. 4 plus 4 is 2, and 4 plus 2 is 0 again, so 4 is 1. 5 plus 5 is 4. 4 plus 5 is 2, and so that's no good. So 2 and 4. There we go. The elements of order 3 are 2 and 4. Now 2 plus 2 equals 4, and if you look back at the table, 4 plus 4 equals 2. So 2 is in H if and only if 4 is in H, since H is a subgroup. So thus H equals 0, 2, and 4. This completes the exercise because we have found all subgroups of Z mod 6Z with respect to plus. There we go.